Alright, in this video we are going to look at a method of factoring called factor by grouping. And as I mentioned in class, the word factor is a verb, it's action. And it can mean many different things depending on what cards you've been played. And what I mean by that is when you get a problem, you kind of have to do a little inspection. And after inspecting the number of terms that you've been given, you can kind of make a decision about how you're going to factor the problem. So in this case, factor by grouping has 4 steps. But the other thing that you also need to know is that this method always deals with problems with 4 terms. And so if you don't have 4 terms, then you're not going to use factor by grouping. So in other words, this is kind of what it will look like. And you can have a plus or minus sign in between each term. But again, this is what 4 terms look like. 4 terms terms are separated by a plus or minus sign. So let's take a look at an example. As you can see, we have 4 distinct terms. And so the first thing we need to do is inspect it for a GCF. As I look down each line, I don't see a common x, and I don't see a common numerical factor. So we're ready to go to the first step. And the first step says to group the first 2 and the last 2 terms. And what that looks like is this. Now there is a condition here. And that condition says make sure there is a plus sign between the groups. So again, there's the plus sign that is between the groups. You don't want to put that plus sign inside the parenthesis. It needs to be in between the 2 groups. Okay, and then step 3 says to factor out the greatest common factor for each group. So as I do an inspection on this group, I notice that I have 2 copies of x here and 2 copies of x here and a common factor of 5. So that gives me 5x squared. When I divide out a 5x squared from this binomial, I'm left with 2x minus 3. And again, you can always do a quick check by distributing that back in, and you should get exactly what you started with. Next, I'm going to factor out the GCF in this group. Upon inspection, I see that it has a positive 3 as a GCF. And so when I divide a 3 out of this, I get a 2x, and a 3 out of this, I'm going to get a minus 3. In the next step, I'm asked to factor out the common binomial from each term. So again, using color here, it helps you to see the common binomial is 2x minus 3. When you remove it from each term, and remember, a term is separated by plus or minus sign. So this right here is one big term, and this right here is the second big term. When you remove it from each term, what you have left is left in purple. 5x squared plus 3. Now the last step is almost as important as the whole process, checking. And checking, I'm going to show you to do this in a particular way because it's really quick. You can almost visualize it and do it in your head. You don't always have to write it down. But I always call this a front door check and a back door check. So the front door is basically the very first piece of each binomial right there. And so when I multiply those 2 out, I'm going to get 10x cubed. And then the back door check is the last 2 terms in those 2 binomials. I'm going to get a minus 9. I'm going to put it down here because as you notice in this problem, the minus 9 is at the end. Now, the 2 middle terms are created by what I call a rainbow check. And rainbow meaning you're going to multiply the 2 inside. You're going to have a little rainbow here, or a smile if you want to think of it that way. You're going to get that answer. The product of that is here. And then your outside one. So it kind of looks like an upside down rainbow. You can actually make those arcs go this way instead of down. But you're going to multiply these 2 terms. And you're going to get 6x. And you're going to notice that that's exactly what you started with right here. So that's how you check it. Let's take a look at another scenario. Now in this scenario, we're going to factor, or excuse me, we're going to group the first two and last two terms, but ooh, we got to stop right there because we have to make sure that there's a plus sign between the two groups, and at this moment there's not. So here's how you create that. I'm going to back this up, and I'm going to put a plus negative 4x. I'm not going to change the negative 12. I'm not changing the DNA of this problem. This minus 4 can simply be written as plus negative 4x. And now I'm going to group. And then the next step, step 2, factor out the GCF from each group. So upon inspection, I see 2 copies of x is common to each one. And when I factor out an x squared, I'm left with x plus 3. In the next group, what I'm noticing is that I have a negative here and a negative here. When you have nothing but negatives, it's probably the best route is to factor out the negative. If you don't, you're going to get opposites. You're going to get negative x minus 3. But in this case, again, it's pretty obvious that both of them contain a negative and also a 4. So I'm going to factor out a negative 4. And as a result, I'm going to get positive x plus 3. And step 3, we're going to factor out x plus 3. And again, when you remove an x plus 3 from this group and this group, what you're left with is what is in blue. And that gives us an x squared minus 4. Now, as always, you should do a final inspection. And a final inspection brings to light the fact that we have another group that can be factored. And this is the difference between two perfect squares. As we mentioned in class, that's a plus b, a minus b. So I can actually factor that into x plus 2, x minus 2. So this problem that completely factored will look like this. The final step we want to check. So I'm going to do the multiplication here first because it's the easiest. I'm going to get x squared minus 4 as a result of that. And then I'm going to do my front door check, which is x cubed, my back door check, which is negative 12. You'll notice again up here you are checking the front door, the back door. And now to get these two middle terms, we call that the rainbow check. The innermost product is plus 3x squared and the outermost is minus 4x. And it checks. Okay, one last question. And this one is unique in its own way as well. So again, following the steps, group the first two and the last two terms. Notice we have that plus in the middle, so we're good to go. Factor out the GCF in the first group. Now it's here where we have to note that there's not really a GCF in this group. So when that's the case, the only thing that you can factor out is a 1. And it's not really even necessary to write the 1, it's just helpful. Okay, in the third step, we're going to factor out the common binomial, which is 2x plus 1. And what remains when we remove this 2x plus 1 from each of these groups is 4x squared plus 1. Now, some people get really confused and they think that this can be factored. But the reason why this can't be factored is because of the plus sign. This is not the difference of two perfect squares. So I cannot factor this as 2x plus 1, 2x minus 1, or 2x plus 1, 2x plus 1. No, it can't be done. So you are basically finished at this point. The final step is your check. So I'm going to check the front door, the back door. Again, you'll notice in this problem we have the front and the back. That's how you get it, is you multiply the two terms in the front and two terms in the back. And then our little rainbow check. It's these two. It's real important that you understand this. These two and the outer two. and you get this. And so as you can note, or will note, that it does equal the original problem. All right, so that finalizes this particular method, and if you can grasp this method, you can actually factor the trinomials using this method, and we'll take a look at that in class. So let me know if you have any questions, and hopefully this has been helpful.